So let's do it. Logs, guys. If I wasn't a teacher, I would probably be a carpenter or something with like logs. So this is my favorite section. First slide is review. We looked at this last week. Okay, it's just b to the p equals a. Just remember, can you take a log of a negative? Keep that in the back of your head, because they are going to throw that at you. You cannot. This is a review. Remember, if your bases match, they cancel. B to the b is 1, and anything, if you ever have a 1 there for any log, it has to be 0. Okay? We'll do some quick examples to review. Let me grab my eraser. Yikers, folks. Logs. All right. Quick review. Rapid fire style. Log base 3 of 3 to the 7th. Do they have the same? That's just 7. We're hitting this one hard because when we get to the actual story problems, we need to remember how to cancel out our bases. Uh-oh, this one's a little bit different, though. Could I rewrite this? Can I rewrite 8 as a power of 2? Yeah. This is a perfect cube, I would know. It's used a lot. 2 to the 3rd. We will see one of those. I do not think they come up on the test, but it doesn't hurt to know. And that'd be 2 to the 18th. Because 3 times 6. Power rules. Now, since they have the same base, now they'll cancel. Okay, so we need to have it be the same base. But I'm going to teach you today how to do that problem. If you forget your power rules, there's a way to do it with your calculator. So I'm going to teach you that today. It's a calculator kind of day. All right. Natural log has a base of e. We need to know that. So those cancel, we get 5. And no matter what number's here, if that's a 1, it has to be 0. Because it's saying 9 to what power equals 1, and anything to the 0 power is 1. Okay? Anything to the 0 power is 1. All right, good review. That's the same thing we just saw. These are the same types of problems. The only caveat, the reason why I want to show you guys these ones, is there's something a little bit different. Natural log e, same base, cancels, gives me a 12, right? Same base, cancels, 4.85. Same base, cancels, 5.9. All right? If you're running through this really fast and you're like, Ms. Twilliger says he's just canceled, I just have to write down the number, you would go to this one and you would say negative 2.1, right? Because log without a number is log base 10. Can we ever log a negative? No. Does not exist. So be careful. They might throw a curveball at you where it's like, oh, cancel, this one's this one's that. It's straightforward. Anytime you see a log of a negative, it cannot happen. It does not exist. Like my bank account now. But my Medicaid benefits were, never mind. All right, so that's all review. Everything we just talked about was rapid fire review. Now for the new. We're going to learn 3 rules. 4, actually, 4. All right. I can expand logs or contract logs if they have the same base. If you're multiplying in your log, you're adding outside. That is the same exact rule as your exponent rules that we did on the first day of this one, right? You're multiplying your bases, you're adding your exponents. That's why it works. That's why this rule works for logs. Okay? Do you guys want, I like to have a little example by these. I don't like just the rules. If I have log base 3 of x plus log base 3 of y, that's the same thing as log base 3 of x times y. Okay? They're equal. All right? Yeah. If any of you someday slip in and take a little bit of calculus, this rule is really, really important. In here, we'll just do some basic stuff with this rule. So if I multiply, add, what do you think I do if I divide? Subtract. It's the same as my exponent rules. When I divide, I subtract my exponents. I have log base 8 of x to a third minus log base 8 of 9. That's the same thing as log base 8 of x to a third over 9. Okay? Again, I like to have an example of it. I don't know about you guys. All right. We're almost done with this lecture. All right, and now for the third rule. It's the same as your exponent rules. These are all the exact same as your exponent rules. If it's a power to a power, you multiply. Okay? So again, let's go back to our log, I don't care, base 3 of x to the fourth. That's the same thing as 4 log base 3 of x. I'll put those in parentheses. Okay? So you can move your exponent out in front. And those are the big three. All right. Adding, you multiply. Subtracting, you divide. Multiply, or yeah, you're multiplying, it's a power. Same thing as your exponent rules. P log, is it really? Never mind. I digress. Yeah, I keep my job. All right, so here we go. Let's write these expressions as a single logarithm. If I'm adding my logs, what do I do with my numbers? When I add, I multiply. 82 times 12. So if you're really a nerd, you could call it log base b of 984. When you add, you multiply. Any questions on that one? You guys feeling okay? Or you're not yet awake? If I subtract, I'm going to go this way. If I subtract, I divide. Check your bases. Make sure they're the same, okay? I don't think I do in here, but there might be times if those bases are not the same, you cannot combine them, okay? That's, I think, 16. Yep. There we go. If that's the only thing that was on the test coming up, would you guys be pretty ecstatic? Oh. All right. We good? Subtract, you divide, add, you multiply. Power, you bring it out in front. So let's do one with x's and really simplify it. Okay. All right, this one's going to be a few steps. I want to write it as one log. And I'm also going to get rid of my exponents. Can I do that? You bet I'm going to. Oh, never mind. I'm just kidding. I'm not gonna get rid of my exponents yet. So, if I'm adding, what do I do with these pieces? You multiply them. What's 9 times 5? 45. And x to the 5th times x to the 6th, or 1 is x to the 6th. Ta-da! You good? If I subtract I, divide. So I do 9x to the 5th over 5x. Oops, not equals, not equals, not equals. Can I cancel out one of those x's? Yes. The less x's, the less complex something is. Even relationships. Sorry. The R and R. Questions, comments, and or concerns? All right. All right. All right, let's look at this beast. Oh no! What do I do with that number out in front? If there's a number out in front, I can move it as an exponent. Okay? So this would be log base b of 5 to the 4th. Okay? You can leave it like that. You could call it 6. Oh, never mind. I'll finish it because you guys are using. That's 625. If you're curious. Now be careful. That 3 has to go to everything in that parentheses. Okay? So that's going to be log base b of 4x to the 5th. Oops, sorry. I'll do to the 3rd. The whole thing. Whole thing to the 3rd. So that's log base b of 64. Now remember, you multiply your exponents power to the power. X to the 15th. Okay? I'm pretty sure we'll get this one done today. Any questions? We're going rapid fire, but you guys feel okay? If you can do that, you can do a lot with logs. All right. Now we're going to throw curveball at you. Okay? It's a way of proving you know your rules without having to type a lot. So you know log base b of x is 4. Log base b of y is 10. So could you find the value of log base b of x times y? Well, could I rewrite this in terms of both of these beasts? That's my question. Can I split it up? I can. If I'm multiplying here, I can rewrite this as log base b of x plus log base b of y. Okay? The only reason I'm doing that is because I know the values of each of those. Log base b of 10, or of x, is 4. Log base b of y is 10. So 4 plus 10 is 14. Okay. Same thing is true with that one. We need to get to look like log base b of x. We know what that is. We don't know what to the 5th is. What can I do with this 5? If it's a power, I can slide it to the front. So this is the same thing as 5 log base b of x, right? Do I know what log b of x is? I do, it's 4. So that's 20. Oh, we're golden. Oh, we'll be okay. All right. I got an idea. All right, let's try this beast. It's going to be a little bit more, but it's the same steps. Same style question, right? We need to split just a log b of x, log b of y. First thing I'm going to deal with is this division symbol. If I see division, what am I doing with my logs? I'm subtracting them. So I'm going to do log base b of x to the third minus log base b of y squared, right? Y'all see that first step? Division, subtract. Then I'm going to deal with these exponents. I can move each exponent out in front. Make it 3 log b of x minus 2 log b of y. Now I can do this problem. Okay, I got down to single logarithms. Log base b of x is equal to 4 because it's given to us, right? Log base b of y is 10 because it's given to us. So 12 minus 20 is negative 8. All right? Here's what I like you do. You're done writing it. Go ahead. I want you guys to try the next one. Try it, and then we'll go over it. All right, let's go over this beast. I'm sorry. So first thing I deal with is that multiplication. So log base b of x to the third plus log base b of b to the seventh. What's log base b of b do? What do these do to each other? They cancel. And then here I'm going to move the 3 in front. And that's 4. I got, what's that, 19? Yep. Okay. Threw a curveball at me. All right, make sure you guys have your calculators on the ready, even you guys in the digital world. Because I'm going to teach you, do you know how I said before that there's all these rules and stuff, and we had 2 bases and numbers, and you had to use exponent rules? You don't have to. There's actually a change of base formula, so now we can calculate any log of any base anytime. Your calculator also does have a button for this. If you have an 84, if you want that tutorial, it's on Moodle. But I'd prefer you not do it that way because you need to know the change of base formula in case they throw an exponent at you. So basically what it is this. That's your change of base formula. I'm going to give you, that's the book definition. I'm going to give you the way I do it every time, all the time. So this is a little bit differently written. Let's say I have log base b of a. And those are both numbers, right? And I can't, your calculator has log base 10 and natural log, right? What I do is natural log of a over natural log of b. Okay? Because I can pick any base. That could be log base 10, log base 5, and it will change the base of this. The reason why I use natural log is 2 reasons. It's one less letter to write, and natural log is more prevalent in biology. So I just use natural log a lot. But this is how I'm going to do it. If you want to start it, well, this formula is going to be used for every problem the next 3 slides. Okay? But it's going to save us a lot of time on a lot of those earlier problems. Instead of thinking about how do I convert the base or how do I do X, Y, I can just use this. So before, I'll keep it up there. We would have said 3 to what power equals 14, right? And then we would have had to reverse engineer and figure out what it is. You know what I'm saying? And that one didn't work. We were like, I don't know. Now we have a tool for it. I can try this one out on your calculator so you get it. It's natural log. Think about this. It's natural log of your big number over the small number. They're already kind of in order, right? So it's natural log of 14 over natural log of 3. And you divide them out and see what you get. You should get approximately 2.40 when you do it. Make sure you're using your parentheses on the top part. You know what I mean? Make sure you're parenthesizing these numbers when you plug them in, okay? Make sure you're putting those numbers in parentheses. Parentheses are your friend. All right. So this piece would be natural log of 90 over natural log of 7. .31. Try it out. See how that's a lot less work? So if you forget your exponent rules and you have a calculator or forget some of the rules, you could get there by doing it this way. Okay? Can I throw a curveball at you guys? You guys are smart, right? You're smart, computer people. Could I have done this in your calculator? Could you do log of 0.5 over log of 7? Is that the same thing as using that formula? Yep, you can use any base, just be consistent. Okay? I'm always going to use natural log, but I just want to remind you, you might see that somewhere. Don't get thrown off. It's the same thing as that. You'll get the same exact answer between those. Well, if I did it that way, or if I did it with natural log, or if I did log base 1 or E, well, that's natural log. They're all the same thing, okay? I just like the natural log because it's not on trend. Is that a good joke? Probably not. Okay. Does it make sense to get a negative for that one? Yeah, because that's a fraction, right? That's a small number. How do you get small numbers? With negative exponents. So that's possible. All right. I'll do this. If you guys ever want to try these and make sure you're doing them correctly, even though it's in the online world, and you want to try these out, you're doing the same thing that you just did. But if you want to know the answers to check yourself because you want to try it, here they are. Okay? So like I said, bigger number over little number, okay? Natural log of the bigger number over, not smaller in terms of value, but smaller in terms of like the little subscript number, right? And that'll work every time you need change base. And that's all I have today.